Right, we're now going to look on how we can actually form what's known as the vector equation of the plane. There's several different types of equation of the plane, but the first one we're going to look at the vector. So first of all, what we're going to do is we're going to click to see our 3 points. Because remember, we need 3 points for a plane. So I've got point A, which I know to be minus 4, 5, 1. I've got this point here, which is P, which is minus 5, minus 4, 1, and I got point R, which in this case is 5, minus 2, 5. However, what we're going to treat R is some general point in the plane, so it's going to move around. If we click here, we will actually see the plane that joins, which is formed by those three. You can see the plane goes all the way through those 3 points, okay? Now, if we click here, oops, sorry, you have to click that first. Click here. What we see is some vectors. Okay, so we're just going to explain each of these. So we've got here the origin. So we go from the origin to point A, and then we do some multiple of a vector AP plus some multiple of a vector PR. And that gives me to a general point R, X, Y, Z. Let's just put it back like that to begin with. Now, if I move lambda, you can see that the point R, this is the original point R, but this is now a general point, which is R dashed. Move around in the plane everywhere. This point's always in the plane. And I can move the other one as well, which will move the other point around P for different values, and I can move these around, and I'm going to get every point in the P. And I can even make them negative. I've got to be careful at that point, because those two, well, that will not make a plane, because it's like having 2 points only. Now I have 3 points again, so I make a plane, and I can move this one back negative to get everywhere in the plane. So I just set those back at their initial values, which is 1 and 1. So in order to make the equation of the plane, i.e. to get to any general point on the plane, and then what I need to do is OR is equal to from OA plus some multiple of AP plus some multiple of PR, and this is the vector equation of the plane. If I look at it now on this from this point of view, so there's a point A, there's a point P, and that's a point R, and R is some general point in the plane. We know that these 2 points can move around, but this one is fixed. And then to get to this particular point here, which is going from the origin to R, going in a roundabout way, I can go from O to A, and then I can go some multiple of P. By making it some multiple, that will allow the point P to move around a bit. And then some multiple of some multiple of AP, and then some multiple of PR. And that will allow this point to move around a bit, as demonstrated in the applet. Right, this is known as R, X, Y, Z. This will be the vector minus 4, 5, 1 in this case, going to this particular point. This point is fixed, it doesn't move. And then the vector AP will be some lambda minus 1, minus 9, 0. You get that by doing that coordinate minus that one. So going back to the origin and going to that one, you get this vector. Sorry, going back against that one plus that one will give you this particular vector here. And then going from PR, it will be mu times 10 to 4. And again, you get that one by going back against the origin, that one plus that one. And that will give you a general point that moves around the plane. So it gives you any general point in the plane, which is what the equation is about. So the general point in the plane is R, X, Y, Z. and we just said O to R, so from O to R is the same as going O to A plus some multiple of this vector here, A to P, and the multiple normally is lambda, plus some multiple of this vector P to R, and the multiple normally is mu. In this case, R, it stands for x, y, z, will be the point minus 4, 5, 1, plus lambda minus 1, 9, 0, plus mu 10, 2, 4. Now it could be 5, 1, 2, for example. It doesn't really matter, it's not unique. So the general form is R will be some point in the plane plus some multiple of a vector in the plane plus some other multiple with another vector in the plane. And this is called the vector equation of the plane. So going back to this is vector A. This is vector lambda mu. And this is vector mu times v. And this is the general form of the vector equation of a plane. So just go back to look at the applet. If we move the sliders around a bit, you can see that you get any point in the plane. You won't get a point. There'll be one point there where you've only now got 2 points in the plane only, but because we need 3 points for the plane. If you move the other one, you can get every single point on this plane. We've got to scale that, but you can look. You get every point on the plane. All right. So this is the vector equation of the plane.